Okay, should I screen share?
Yeah, I think we're good to go. Yeah.
Okay, but do you see this?
Yeah.
You should see this shared screen, right? Okay, good. So what's the idea of the hands-on sessions this afternoon? We have 3 hours, and so this is with Brian and with me, and the plan of the sessions was to, in some sense, go through the examples and part of the lecture material that you saw today, and in some sense, yeah, to reproduce the results, get new results, and yeah, get some practical ideas of what I was showing there. So this will also include actually example codes for neural nets that you will train for ratio estimation. And so let me just briefly go through. Everything will be based on a Google Colab notebook, and you find the link to this Google Colab notebook at the end of my lecture slides. I'm not sure if this was distributed or is distributed. Miguel or Brian, do you know? Or maybe students can tell me.
Maybe it is also convenient to put it on the chat.
That's a very good idea.
Yeah.
I will do this now. Yeah, that's actually the... Okay, let me get the right one. This will take a second. Okay, there's now a link in the chat, which should be the correct one. Okay, so you should see the link. If you click on the link, you get to some version of this here. Okay, this here is just the version with output. I put now the link to the version without output. And the idea is you can go through the Google Colab notebook. We will all meet in Gathertown in some huge classroom. And if you have questions about the exercises in the Google Colab notebook, you can just ask either Brian or myself, and we will also be walking around and can talk. And you can also talk to each other. There are some, like, I can show you maybe. So it looks like this here. Okay, you find this if you follow these blue arrows. It's up here in the corner, this room. Okay, I think it wasn't there before. So yeah, you can just do the exercises here, and then we can easily communicate. And the idea of the exercises is to yeah, look at this simple toy model that I was presenting with diffuse emission and point source emission. That's the model that produced these images that you also saw during the lectures. And yes, is there a question? Okay.
Yeah, there are questions on the chat. Oh no, it's just.
Where can we find the lectures? Okay, that's easy.
Yeah, no.
So just a second.
But for that, maybe.
Okay, should be this one. Good. Yep. So if you click this Google Colab notebook, does it work? You are not supposed to edit it. You are just supposed to copy it. So you will not have. You should have access rights, but you don't have edit rights.
I think it works. At least someone.
Okay, good. Yeah.
Lorenzo,
and the lecture slides are just here. I mean, they are HTML, so you can just go through them and stuff. And there are, at the very end of the lecture slides, there are links to the documents that I just mentioned. Okay. And there are actually links back from the notebook to the lecture slides so that you can find explanations if needed. Okay. The idea is, well, looking at this example here, right? And then you can play a bit around with this, explore the image generator, typical variations of the images. Then we will be doing some Fisher forecasting. So instead of doing, for instance, this 1-point PDF for getting point source parameters, you can just do some Fisher forecasting to estimate the expected reconstruction uncertainties. And this is given code, so you don't have to write this by hand. And if you want to have the details about Fisher forecasting, you can click on the link and will end up on the lecture slide that I skipped about Fisher forecasting. So the point is simply to highlight what you could learn from doing such an analysis, so that you have an idea. Is this a question? There's an enormous feedback. Thanks. Good. So there will be Fisher forecasting. If you have questions about that, we can talk about this. So this will be about point sources, and then you are supposed to reproduce this for the templates, which is a much simpler example in some sense. So you just have to understand the definitions of Fisher forecasting and then re-implement this for estimating then how well you could maybe reconstruct in an ideal world the template parameters, the three, so the diffuse emission parameters, the three that we discussed. Good. So the idea is here to just give you some intuition or some basic idea for what you would expect from these classical type analysis things. Okay, but instead of doing them, you will just like forecasting them, which is simpler. Good. And then the next step is to do some neural ratio estimation. And since you are probably most of you will have no prior experience with training neural nets, there's quite some reasonably detailed explanation about what the individual steps are. So we provide the entire infrastructure to do the training. And you are just supposed to do it and explore a bit how things change, what they depend on, and so on. So in the end, you will produce plots like this here. So you train a neural net to, in this case, reconstruct the normalization of the disk component, keeping point sources fixed, not fixed, so they vary, but you don't vary the point source population parameters or the other parameters. It's just like a simple experiment so that you see that in practice it works. And you see after you train the network, you can plug in all kinds of images and you get instantaneously the posterior out. So that's something I didn't like discuss in detail, but the point is if you train a network afterwards, it's not only like solving a problem that otherwise wouldn't be solvable almost, but it's also solving that problem almost instantaneously for almost any observation. So it kind of memorized all kinds of solutions. And you can see this here. So afterwards, you just plug in different images as the ones that you saw up here. And for each image, it will give you like a posterior for the normalization of the disk component. Good. So you might appreciate after going through this that it's kind of a bit of a pain to do this by hand each time. And so what we did was to write a tool. Actually, we do this now since almost a year, and it has changed a lot. But the goal with this thing, with what we call Swift, was to do a bit what I guess Multinest was doing for nested sampling, but in our case for likelihood-free inference, to have a tool that just works. Turns out it just works, but not always. So it's not entirely. It doesn't work as like black boxish as Multinest or other samplers. So you have to put in some thought, but it's certainly much easier to use than writing everything from scratch. So you will here get a reasonably detailed explanation about how to set the thing up, and then you will train on this kind of training data a neural net that will then extract the diffuse emission parameters. It will not work very well on the point source parameters initially. Then you can explore also convolutional neural net, and then it will start working better on the point source parameters. And you can then compare the reconstruction uncertainties with what you would have expected from Fisher forecasting if you would have done a classical analysis. And yeah, I guess in 3 hours you roughly will get there. If you have time, you can like also train 2D posteriors and get correlations of the parameters and stuff like that. Yeah, so it's the entire exercise set is supposed to get you a bit into like contact with these neural network techniques. Certainly not exhaustive whatsoever, but it's hopefully like lowering the threshold for you in the future to try some of these techniques. Yeah, if there are urgent questions, we can discuss this now. Otherwise, we should just all move to this room. I see you already there. I hope everybody was still listening. So we meet in this room in a second.
Yeah, let's. If there is no urgent question on that, as Christoph said, let's all move there and continue. That is just. I have just one question for Miguel or Alejandra. So, how do we do with the streaming on YouTube? That I don't know.
With the recording, I have no idea.
So the recording, no, right? It's more complicated the recording. So let's. Yeah. So then I will stop recording on YouTube now, and we move to gather time. Okay.
See you there.